So this was the problem that we stopped or was not able to answer yesterday. I'm sure there are some other geometric theorems that you can use to solve this. I just have forgotten, but I'm gonna solve it a different way. Okay, so but before we do this, we want to review a couple of things. Okay, so the concept of central angles. Okay, central angles and also SOHCAHTOA. Okay, and I think SOHCAHTOA we have discussed before. Okay, so central angle. So say for instance, this is your circle. This is a circle, and this is the center. It has to be a center. Okay, and then you have two radii. So that's one radius. This is another radius. Between the two radii, and you have the center as your vertex, you create an angle. And let's call that one theta. Okay, so the measurement of that central angle is equal to the arc measurement of this arc that it intercepts. So let's say this is 80 degrees. Then this angle right here is also 80 degrees. Now, for instance, you have another circle and you have some point somewhere inside the circle and you have some kind of segment and another segment. Of course, again, it creates another angle, let's say beta, and it has an intercepted arc in here. And let's say this is 70 degrees. Then that means this 70 degrees is not equal to this beta right here because the vertex here is in the circle but not the center. Okay, so this only works, the central angle theorem only works if the vertex is the center of the circle. So that's why it's called central angle. Okay, so that's one concept. The second concept that we would like to review is SOHCAHTOA. So let's say you have a right angle. Of course, for SOHCAHTOA, sine, cosine, tangent, right? You have a right angle, and let's say this is your reference angle. Let's call this one beta. Okay, now with respect to beta, this is your hypotenuse right here. The side that is opposite that reference angle is called opposite side, and then the side next to it or adjacent to it, it's called adjacent. Okay, so if we want to find sine of beta of what that angle, that means sine is opposite over hypotenuse, so that's O over H. If you want to find cosine of beta, then that's adjacent over hypotenuse, so that's A over H. And then if you want to find tangent of beta, then that means opposite over adjacent, so O over H. Okay, so that's the review that we'd like to cover. Now, why did we need this? Okay, so if you consider, let's consider this arc. This is 40 degrees, right? Now that 40 degrees, if you draw a radius from here and draw this radius from here, because this O is the center, then that means this is a central angle, right? So that is a central angle. Since that is a central angle, then that's equal to the arc that it intercepts, which is 40. So that means this is 40 degrees as well. So now what I want to do is to capture this triangle. Okay, so this triangle right here with X, and this side right here, and that side right there. Okay, I'm going to capture that over here. Okay. So since this is a central angle, then this must be 40 degrees. Now that is 90 degrees, so therefore this must be 90 degrees. This is your radius right here, so therefore this is also 10, and this is your x. So from here, you can use your SOHCAHTOA now. So this is your reference angle, 40 degrees. So that means this is your opposite side, and this is your, that's 90 degrees opposite, that is your hypotenuse. So therefore from here, you can use sine, right? So sine of 40 degrees is equal to the opposite, which is x over 10. So solving for x, let's cross multiply. So x equals 10 times sine of 40 degrees. So let's find that one out. Okay. Let me just check something if it's, this is, how do we clear this thing? Okay, so I want trig. Let me just check sine 30. Okay, so that's not doing that. Okay, so that's how you use this. All right, I didn't know how to use this calculator. Okay, so it says 10 times sine 40. So I'm gonna do 40, and I'm gonna find the sine of that, and I'm gonna multiply this one by 10, and so the answer is 6.4. So therefore x is 6.4. Okay, and so that's how you find this. Now it depends on what's given. Okay, so if you're looking for x, then that means that's 6.4. If you're looking for this distance right here, then you gotta use, if you're looking for this, let's call this one y. So that will be adjacent, and you have hypotenuse, then you will use cosine. All right, so I hope this helps.